So
very wordy in my titles.
that's okay. Well, it describes what you're doing. That's what you.
I know. I should
Wanna,
come up with something
yeah,
a little flashier.
yeah. So. Okay. All right. Why don't you? Can you hear that reverb in there?
No.
Oh, good, good. I'm hearing too. I'm hearing from my PC and from my. Okay, we're all set to go. I don't know. Basically, please welcome Peter Koletzke, who's going to be talking about using PL SQL tables to implement smart DB thick database principles. So without further ado, so please proceed.
Okay, thank you, Mike. Yep, so what he said is basically the title. We're talking about Table API today. Oracle ACE director and currently kind of independently employed. Been a developer for years, since SQL Forms 2.3 and Oracle Database 5.1c, those good old days on the PC. So I'm going to start by finding out if any of you have these situations in your environment. First scenario is a legacy Forms application written in Forms 3.0 or even 2.3, where there was no PL SQL in the 6.0 database, and it was migrated through to newer versions. So, it's through 4.0, 4.5, 5.0, or directly to 6.0 or later. What we're seeing on the screen is a 4.5 screen. And then maybe you're up to 12.2 or 12.0 now, 12.2 now, which is the current version. But the PL SQL that was written in the forms back in the 3.0 days or after is still in the application. It's not in the database. So that's one scenario. Second scenario would be a Java application that Java developers have developed, and they've created the database objects based on their Java objects. So the Java objects were created first and then migrated over to tables in the database. So all the logic, database logic is written in Java code. SQL is written to go through Java to the database. And there's little or no stored PL SQL in the database. It's all SQL within Java code. Scenario 3 is a JavaScript application, so a little bit more modern technology that accesses database objects through server or client code. So SQL is issued directly that way. And again, little or no stored PL SQL. So lots of back and forth between the client, either the client or the application side, JavaScript, and the SQL side on the database. So result is these systems work fine in test and QA. Even in user acceptance testing, everything's fine. And you may or may not be doing load testing. And of course, if you don't, when you get to production, you'll find performance is lagging because you've got increased time for accessing database with multiple clients, lots and lots of messages going back and forth, time in the database taken to interpret the messages and handle the messages. And all of that means that the application gets slower. The other effect is that when you change development languages, you have to rewrite the application completely. So if you're going from Java as your main user interface technology to JavaScript, for example, or if you're in the Oracle world, JET, which is JavaScript Extension Toolkit, then the application code, if it has the SQL built into it, all of that has to be migrated completely over to the new technology and rewritten, possibly in whatever access protocols are out there. So the solution is thick database, where you've got PL SQL in the database. So we'll talk about this topic in really 4 sections. The first is, what is thick database? you may or may not have heard the term, or may have heard some related term, or you may not have heard it at all, and you still may be using some of these concepts. So I'll talk in the second section about how to implement a table API, which is the kind of key feature and key technology technique that you would use to implement thick database. And then we'll kind of backtrack and say, why do we want to do this? Why do we do thick database? And then talk about some variations and strategies, things you can think about for your environment if you haven't already. So we'll start with what is thick database. Oh, and by the way, the slides with a Q&A document, which was created in another session that I did with a user group. People asked questions later and I answered them later. So I documented all that in a question and answer format, and that's going to be attached to the slide file, which will be on Mike's blog. And the recording of the session will also be there. So you can replay this again if you really want to. Oh, and then code samples. I'm going to be showing you some code to basically as examples of these techniques, and that's at this short link here, and I'll repeat that at the end of the talk, so you don't have to madly screen capture. But again, that's also in the slides that you can download. So thick database is a code development strategy. Basically, it's not any kind of product. It's not really anything that you can go out and buy or download. It's the key kind of the key objective is that you're maximizing the use of database code, and that simplifies whatever you're writing on the user interface side. So the user's device is running minimal code. And the other names that you might see for this are thick database approach, thick database paradigm, fat database, which is not as common, maybe less politically correct, smart database, smart DB, and Oracle actually prefers those last two. And the name comes from when we were talking about, you're the internet term, thick client, or thin client rather, it's a kind of the opposite to thin client, which means you're doing processing on a server rather than on the client. So a thick database means thin client. So smart database and smart DB. If you look out on the Oracle website, the Ask Tom office hours had sessions that were oriented on this too, and you can find Oracle mentioning smart DB as a thing. So it's out there. And then I just wanted to mention that Dr. Paul Dorsey of Dulcian was an early kind of purveyor of this idea, and maybe not inventing it, but he proposed it to user groups often. And there's resources on his website, which I'll mention later, sessions that he's given and his colleagues have given that explain it more. So the most important thing is that this is not a product or something you can download. It's a strategy. So the realization of these principles is up to you. And what you're going to see today in this talk is my way, which is not the only way. So there's no one way. But I've used this for over 10 years successfully, and I've implemented the basic strategies, which are centralized code in the database and minimizing the client-side code and then protecting the code from tampering. So those are kind of key objectives of the strategy, which again, you can implement in multiple ways, but I'll show you my way. Companion strategy to this is to have some kind of system for tracking business rules. The idea with thick database is that you're implementing your code in the database to validate data and to make sure that data integrity is ensured. So this all falls into the category of the way the data needs to be in the database for the business. So business rules is all about that. So if you have a system for tracking this, you can write these business rules in a user-friendly syntax and present them to users and validate your design and work that into the specifications and even into the test plans. You can also store these definitions in database tables, so they're easy to query and easy to change and rewrite and translate and edit. With a little more effort, you can link the business rules to your code and to test plans. So you can actually generate test plans from the statements that you've written in the database for business rules. and the code implementations can be cross-referenced to the business rules. So when you're done with your implementation in development, you can say, well, this particular piece of code implements this business rule, or this set of business rules, and then kind of prove that you've fulfilled all of the requirements. A little more effort, you can have a system that generates code from the business rule definitions. And this means you've got to have some kind of machine readable syntax, something that you can parse out and say, if this statement's written this way, we're going to actually create some PL SQL code that does this, with if then else statements or with queries or whatever. So that's a little bit more effort. And then and an example of that would be Oracle Apex, which you're basically defining elements in the screens that you use to create your application that are stored as database metadata, and that metadata creates PL SQL code, which is your application. Although there are some things that you can't do that way, so it's not a complete system for generating code, but you can get quite a ways along without having to write custom code. And with a lot of effort, this is kind of the ultimate in effort, you can read the business rules dynamically and generate code on the fly. So you're actually not generating any code until runtime. And that means ultimate flexibility, of course, because you can change things and the application is already changed when you do that in the metadata. But it's a lot of effort because you've got to have fairly deep code for figuring out how to make that happen on the fly. But there is a system, a product called Business Rules that Oracle has. It's out there for a while, and it's considered originally kind of part of the service-oriented architecture, the SOA suite, but it's an individual product that you can use as well. And it lets you define rules and kind of in a human syntax, and then those are stored as metadata in XML, and then they're read on the fly in the application by a service. But the goal is to maintain data integrity. That's the ultimate goal, using database objects. And database constraints like check constraints, not null, and data integrity, or referential integrity rather, constraints only go part way. You can have triggers that supplement that constraint, but they fall short if you're doing cross-row and cross-table validation, unless you write a lot of code. So they're available, but they're not a complete solution. So you have to write procedural code to fill the gap, and this is all PL SQL. And I mentioned this create assertion statement, which is a SQL standard, but it hasn't been implemented yet by any database vendor that I know of. And Oracle talks about this in this link down here, but it's basically a way that you can define database constraint or database object, which is an assertion that does the validation for you without lots of code. It would be without PL SQL. So we don't have that yet, so now this is what we're doing. So it brings up the question of where do you put the code, and why are we talking about database? The goal for this strategy, thick database, is to always validate data using database code. That is the goal. Because constraints and triggers can help you, but you also need PL SQL procedures. And forcing the table access to be only through an API, application programming interface only, lets you make sure that the data, regardless of the application, will be valid and will be integrated. So simple non-SQL variations can be repeated, validations rather, can be repeated in the code, like number of children as a positive integer or birth date is on or before today. Those kind of business rules can be implemented also in the client, but they definitely should be done in the database as well as a constraint or something else. So the idea, main principle, always have code in the database. So there's kind of another way to put it, just in case you don't get the picture. All right, so how do we implement a table API, which again, like I said, is a core technique? Well, first of all, about the schemas, protecting the code is one of the objectives. So you have a connect schema which users a common connect schema which users access, and that has grants to the table owner schema, which owns the PL SQL code and tables. So this is one variation. There's a couple more which I'll go into, but the connect schema is often done as a single schema that application users log into using their own login. So they log into the application server, for example, and that login is personal to them, and the application server tracks their session individually as their personal user. But when you connect with the database, you use a common user that all users share. The second option is 3 schemas, which is again the connect schema, but another one that just owns the PL SQL. And the third is the one for the table owners. So it owns tables, but the API and any views or business rules code table API is in another schema, in a middle schema, with auth definer, which means that there's more protection on, more control over how it accesses objects. 4 schemas, and this is one that was proposed and I guess forwarded by Bryn Llewellyn in this white paper, Why Use PL SQL. And you can look that up. Just look up Why Use PL SQL if you want to get to it. He goes into great detail about this technique and in general why using PL SQL is a good idea if you're not convinced already. But he does explain this 4 schema one, which is the table API and business rules code are separate. So you've got 4 schemas. You've got the table owner, the connect schema, the API schema, and the business rules schema. They're all separate. And then synonyms are optional in all these cases. You may choose to have prefix, the schema prefixes on all your calls to have the ultimate control. You also have to have some kind of guard against someone going in to do grants that were not designed into the system, that kind of give somebody the ability to circumvent these protections, and also creating synonyms. So DDL triggers can help with that. And of course, grants, specific grants to specific users are always the best protection. So what is a table API? The way I define it is it's a PL SQL package for each table. And all the modifications for that table, insert, update, delete, lock, is accomplished through procedures. So you have a procedure in that package for insert, one for update, one for delete, one for lock, and then that's single row. And then you would have multi-row versions of all these that would handle collections, either PL SQL table parameters or ref cursors or some kind of object, collection object. But what I'll show you in the examples that we're going to look at in a second are single row examples, and you can kind of extend this into multi-row by just saying, well, we'll do for an insert, we'll do a for all type of operation on this collection, and then that'll be a single statement that will do multiple rows instead of the single row insert that I'll be showing you. So use the bulk collection type of statements in PL SQL for the multi-row. So the procedures will call business rules validation code that will make sure the data is valid before the insert, update, or delete happens. And this is the key piece. So you're doing everything through the table API and granting only to that table API. So users can't do SQL statements directly, insert, update, delete. They have to go through the procedures. So there's no grants directly to the table either. Okay, demo 1 is just really to show you some examples. And again, the samples that I'll show you are all at this bit.ly/tappy_code link. Get them. So we'll jump over to SQL Developer. And I'm showing, this is an example of a table from the HR system samples that Oracle has been giving us since the beginning, I think, of Oracle. Employees, departments, and jobs, locations and regions tables. So this is the jobs table. The reason I'm showing the jobs table is because it's the smallest number of columns in the set of tables that they give us. So here's the package spec, basically, for the jobs table API. And the first thing is creating a record and table types for the columns in that table. There's 4 columns, so there's job ID column, minimum salary, job title, and maximum salary columns. So we're creating the record variable, and then we're creating the table variable from that. So we can use those in our procedures. So the next one is the insert statement, the insert procedure, which is just the 4 columns, which are the 4 parameters, and then a version of that for the row, in case you wanted to send a row type in for the parameter instead of the individual column names. Same thing for update. So with an update, you might want to check the old value and the new value and do, there may be some business rule that needs to know that, or you may want to alter your update statement based on what actually changed in the table. So this is a simple version, which is just the new values of these columns. And it could be that some of them are not changed, so you wouldn't make a change to those. And again, the row type version of that procedure. And delete, we just have a single one which passes in the ID of the row primary key and then does the delete, and lock the same thing. So that is the specification. And then if we look at the body, this is the insert statement. Again, the individual parameters for individual columns. And what I do for the system that I've been using is I create a message variable at the beginning, and the return value from my statement, my business rules statement, is a message that if there's an error, there's a message. If there's no error, then vMessage will be null. So we'll look at check jobs insert in a second, but let's say that this is null. That means that we can go into the insert. So we pass the parameter values directly into the table, into the insert statement. So it's a standard insert. And if there's a problem with the insert for some reason, we don't know what, then it raises an application error. If there is, and then the application error basically is not handled here, which means it's passed back to the caller. And the caller and the error message will include whatever the business rules error was. And that will be parsed out by the caller and presented to the user. So let's look at this. It'll make a little more sense when we look at this particular statement. So the jobs BR is a package, and check jobs insert is one example. So let's look at that. Here's the jobs BR package, passing in the 4 parameters of the columns, and again, a row type. And I didn't write the check jobs update or check jobs delete business rules here. So you would just use the same kind of idea, based on what rules have to occur with updates and deletes. But this is for the inserts. So the package body, we're passing in the parameters, and again, we create a return variable. Oh, and then I have a to-do, which is externalize the messages, the business rule errors in a table. If you've got a multilingual application, that's important. And even if you don't, changing the messages is easier if they're in a table, so you don't have to recompile all your code. But I've hard-coded them here just in case, just for simplicity, examples. But there's a to-do, and I will work on that eventually. So the business rule, I give my business rules numbers because I store the actual description, the actual syntax, both in a user format and also in kind of a shortened format that developers can read in a table. And the tables have numbers, the rows have numbers, so the ID number is what I'm putting here. So business rule 14 is minimum salary must be filled in if maximum salary is filled in. So we're just doing a quick check here and returning this error, and I'm concatenating it. I have a concatenation procedure, which I'll show you in a second, but it just does a quick check of maximum salary, minimum salary, and then returns an error into the error statement. And then I'm checking the next one, which is business rule 25, max salary must be greater than or equal to min salary. So same thing here, and then adding, concatenating the message. Rule 34, PRES, president, is a reserved job ID. So we can't actually enter a new president through, there's only one, and we can only enter it through some back-end administrative routine that nobody can get to. So it's not valid for a user entry. So that's the business rule. And so we just have this job ID pres is not allowed return if the user assigns that job ID. And then at the end of this, we've concatenated all the messages together. And actually, you'll see when I show you that there's a carriage return between each of the messages, but we're surrounding it also with curly brackets. And the reason for that is when you get an application error, you'll get an Oracle error. It's Aura dash whatever your user error number is, and then it'll show the message. So we don't need to have the user see the Aura error number. So I close it in curly brackets, which I can parse out more easily later on in the application. It's fairly easy to parse out. So let's look at error package really quickly, because this is handling the concatenation and also the delimiters, the start and end character. So here's the delimiter. This is being inserted in between messages in that concatenation procedure. And then I've got curly brackets start and end, which the caller can extract the message from. So concat message, handle tappy error is something else. And the distilled message, which we'll look at too. So concat message just adds the delimiters, and handle tappy error, I don't have anything in that yet. So this is if we wanted to insert the errors into an error table. For example, instead of returning the message directly as a raise application error, we want to insert the messages in a table, and then the user interface reads that table to see if there are any messages. It's just another way to think about it. Distilled message, this basically just parses out the Aura error, and based on those curly brackets beginning and ending, and then it also puts the delimiter, or it trims off the last delimiter. So that's kind of very simple thing. So let's look at how that works now. This is an example. So jobs tappy.ins. So we're trying to do, this is the call for an insert that we would insert in our application. And we're inserting job ID, minimum salary, no minimum salary, job title, and maximum salary. And notice maximum salary is there, but minimum isn't, which is a violation of Business Rule 14. So we're going to get an error message, and I'm going to actually, why don't I show you what the error message is without parsing it up. All right, so we'll just do a DBMS error on that, a DBMS output rather. And so what we see in the DBMS output window here is the exact string that comes back. So we have the Aura error, because that's the one I assigned in my business rule package, to the, and then the error message that came back from the business rule. So if we do the parsed version of that, so comment this out, uncomment that, and let me clear this so you don't have to see what's there, and we'll run it again, and it's just the error message. So that's the idea with all of that stuff. All right, so there's two calling methods that I've used. One, and they both use these data validation procedures and the table API. So you're calling the ins, ups, up to, and del procedures within the table API. But method one, you're calling those procedures directly in the client. So you're basically calling PL SQL procedures. You're not doing SQL insert, update, delete statements from the client or the user interface. The second method is you create a view on whatever object you've got that you're looking at in the user interface. And when the client issues SQL to that, insert, update, delete SQL to that database view, there's a database instead of trigger that calls the database, that calls the table API procedures. So instead of having the table API procedures called by the client, as in method one, you're calling it from the view trigger in the database. variation on that is to have a view. In the view trigger, you call view API procedures. So in addition to a table API, you also have a view API that call the table API procedures. And it depends on how complex you want to look at it. But in all cases, you're using the table API. Oh, I didn't fill in that blank. Okay, so but in any case, they're always the table API. So wait, we'll go back to this one. And look at the first method first, which is, again, procedure call instead of SQL for insert, update, delete. So the client has to do the commit. Instead of having it in the statement itself, the client's going to do the commit. And there are some tools that are more oriented towards SQL calls, in which case you would use method 2. So we'll look at method 2 a little bit later. But the benefit for method 1 is that you can access any table or statement because it's a procedure call. When you use a view trigger or some trigger, as in method 2, you're limited in insert, update, delete by the mutating tables problem. So that has to be considered for cross-row and cross-table access. So we're going to look at how that runs. And actually, this is really just a repeat in SQL Developer of the one that I just showed you, but it's a little more extensive. I've got a check here. This is kind of my test plan, my test procedure for all the business rules that I've got in my system. And I've only got 4. So don't worry, we're not going to spend the next half hour just looking at my business rules. All right, so the first one is Rule 14, which we just did the test on. So you saw what the output of that was. The next one is Rule 25, which is min salary less than max salary. So you'll see the minimum salary is greater than the maximum salary, which is not right. Next one is job ID is press, which is wrong. We cannot allow that job title to be used in a new record. And the last one is testing 2 of the statements at the same time. So we're doing press and we're also doing minimum salary greater than maximum salary. So we should actually get 2 error messages. So let's run this and see what happens. I'll clear that window and we'll run this as a script, the whole set of 4 calls. And let's look at that. Now I put in, after the asterisk, I put in just headings so I know what the statement's all about. So those wouldn't be in the actual business rule statement or the actual insert routine. So the first one, I got the message that I expected. Second one, same thing. And minimum salary must be the same as or more than maximum salary must be the same or more than minimum salary. And then job ID press is not allowed. And then the last one was the 2 errors, which was both Rule 25 and 34. And I got the 2 error messages on separate lines. And that's because I was able to parse out the curly brackets and then leave the carriage return in between. So that would be the case if there's more than one statement. And again, this is just one way that I've done that works. But again, you could have each of these statements inserted into a table, and then the user interface would read that table at the end and present all those messages and however it needs to present it. All right, so now what about method 2? So method 2, again, is the database view and a trigger, an insert trigger, instead of trigger. So whatever view you've got in the database or whatever tables you've got in the database can be represented in a view. And a view can really be any kind of, arbitrarily complex statement with any kind of data in it, any kind of table in it, or any kind of code. And then that can be represented by instead of trigger, which can do anything. So you're not limited to the tables that you're querying. You can really, from the instead of trigger, you can fire off procedures that do anything. So we have insert, update, delete row level trigger in the instead of trigger. which calls the table API. So we'll have that insert, update, delete procedure call that we were looking at in the table API called from the instead of trigger. And the reason you're doing this is to simplify the user interface access to the table. So you're just doing SQL insert, the actual SQL insert, update, delete, not the procedures, but the actual SQL to the database view. And then the database view does whatever it needs to do to the tables, to whatever is needed for the user interface. Some validation needs special handling in this case. So because it's a row level trigger, you're only doing a row at a time. You can't call the multi-row, well, you can call the multi-row procedures if you've written them in the table API, but they assembling a collection is not possible. You only get access to the row that's being updated, inserted, or deleted. And also a statement level trigger may be needed for tables if you have a non-transactional procedure, which is basically checking data in another table. If the table is related, you may get a mutating table error if it's a row level trigger, and that can be a problem. So there are things that you may have to do outside of this system to validate for cross row and cross table validation. Oh, and this is, by the way, this is trigger, who is Roy Rogers' horse, which of course you recognize. Okay, demo 3. Demo 3 is really just showing this view and the trigger system that I'm describing for method 2. So we'll go back to SQL Developer, and I've got a view which is called emp details VW, and it's basically all columns in the employee table, and then selected columns from department, job, location, country, region, and then a join between all of those, an equijoin between all those tables in the system. So 6 tables, and they're joined one to one. So we're showing the employee, the example user interface would be, we're showing an employee record with all the details of that employee, including location, country, department, job, and all that within a single record. So that's the view. And then the instead of trigger is written on that view. Instead of triggers are always row level. There's no statement level instead of trigger. And we're replacing insert, update, or delete for the statements, those statements that are issued to this view. And so if inserting, we're passing in new values for all the columns, and then this employees package is the table API for that package, would do its insert basically the same as what I showed for the job table. It would have the check insert business rule procedures that would check the data, and then return an error message if there was an error or not. If there's no error message, then everything proceeds. And same thing for updating, passing in only the new values in this case. But if it's, again, a case where you need to compare old and new values, you would also pass in the old values. So you'd have old.employee ID, old.firstname, all those as well. Create a procedure that would handle all that. And then deleting is, like before, it's just the ID of the row, which is all you need for the delete. So that's the simple version of the business rule view trigger. Oh, and we could look briefly at the employees package. So again, it's pretty much the same. This is the specification. Insert passes in all the rows, all the columns rather. Update. I don't have the row level or the row type procedures defined in this one, but they would be if you need them. And then in the body, we pass in all the parameters, and then this one's commented out because it's still underway, but this is an example of how the business rule code would be called. I'm calling it directly from the employee package, but I would want to, this is the, I may want to put this procedure in a separate business rule API package. So having the table API just as insert, update, delete procedures, and then having a separate business rule package for the check procedures. That's one option. And I think the reason I do that is because these can get quite long and involved, these check procedures. So this one's doing something with hire date and start date. Yeah, the hire date has to be after the job's, when the job was created, the job originally. So stuff like that. So the way it works is the insert statement does the same thing. It calls the check statement, and then if there's an error message, if there's no error message, rather, it does the insert. Otherwise, it doesn't raise application error. But you'll also notice what I've added to this one is this global variable, gallow DML. If you look back at the spec, that's defined here, and it's a default value of false, but you can set it back to true. And when you do that here, then that's set in for the session. So when you go to a trigger, which is this trigger, if this is not set to true, then you'll get an error message. So the default is false. If you don't call the table API to set it to true, you'll get an error that you cannot do statements to this table directly, insert, update, delete. So this is a way to enforce not being able to call SQL insert, update, delete, but only going through table API. The other way to state that is you must go through the table API to do insert, update, delete. So this is the trigger that enforces that. So that's what these statements are. You set it to true, and when you do the insert statement, then that trigger will allow that insert, and then you reset it to false at the end. Or if there's an exception, you reset it to false. That's the other possible option. Okay, I think that was the idea there. So just diagrammatically, what's happening with this method 2 is you're issuing the DML, and I put DML in quotes because I'm talking about insert, update, delete, and technically, select is part of DML, but I'm talking about the insert, update, delete part is issued to the view, and the instead of triggers is protecting the view, so it fires instead of the actual SQL statement, and the view then calls off to the other table APIs. I was just showing the example of the one call to the employees table, but you can call any and all or none table APIs from that instead of trigger. And then those go through the table triggers to get to the tables. And if the table trigger has that protection of not being able to do inserts other than the API, then it'll stop that statement, whatever it is. And it also stops statements coming from the outside. So if they're not coming through the API, then they'll be stopped. I should look and see if there's any questions, because you can ask questions. Not there. You're going to ask questions.
Yeah, not at this point. If you have any questions, either put it in the Q&A or chat, or if you're on YouTube, there's a spot where you can enter questions as well.
Oh, great. Thank you.
Yeah,
all right, so we'll check it as we go along and check it at the end too. So we'll make sure that we're all copacetic. Okay, so that was the optional table API component is the one I was just showing, which is that trigger that stops DML if there's an insert issued to the table directly. So this is just all explaining what I just showed you, and that's the trigger statement again in color. Living color. All right. All right. So that's kind of the whole idea about all this. So how do you create the code? Well, generating the stub code is a really good idea because there's, as you notice, there's a whole lot of kind of repetitive stuff, right? You're doing a lot of percent type things and percent row type things, and then you're also making sure that you represent all the columns in the table and maybe spelling them correctly, and trying to figure out, what the order of the columns is in the statements. So a lot of this stuff can be done with automation, and that will give you a good starting point. Obviously, it won't write your business rules code for you unless you've written some kind of generator that you're reading metadata from that you've created. So there's metadata and there's generators for that. But it'll at least give you the code that you can use for the base part of the table API. So one idea is to use a pre-built generator, which the two that I mentioned here that I've got listed here are extremely powerful. Actually, they take a bit of getting into, but they're very flexible, and I can't say that I've used them because they were kind of issued after I started all this work, and I kind of created my own instead. But they're definitely worth looking at if you don't have a way to generate the stub code already, and maybe even do more than the stub code. You can customize some of the code that it creates, so you're doing maybe even adding the check procedure calls, which is a good idea. Rolling your own generator is another idea, and the demo for that is really simple. It's basically what all these generators are doing is they're reading the data dictionary, right? So like I'll just do an example of user tab columns and for the employees table, and this is just reading the columns basically from that. So we can run that, connect to HR, and then we get a bunch of the whole list of columns. So we can copy and paste that into our code, or a value statement for an insert rather. So put a p underscore as to signify parameter for the columns that are in the value statement. Parameter list, you add the % type to it when you've got those lists that you're putting into the specification and body and procedure headings. So all that stuff, you can just create little individual generators from, and then you could surround those calls with the code like the begin, declare end, or all that heading for the procedure name and all that with, whatever you need to create the code. It's a lot of work, but you could do it. And that's kind of how all these generators do it. Other option is SQL Developer actually has a table API generator. So I'll show this live, but it's basically through the table menu. So if we look at our HR and tables, I'll zoom in because it's probably very small. So I just expanded the tables node in my schema, and then we'll do it on jobs because that's what we were looking at before. Right click, table, generate table API. And then of course, Control F7 to reformat. And if you look at this, it looks almost exactly like what I just showed you. So we've got the record and table variables. We've got the insert, update, delete procedures. We don't have the record type versions of these, but those would be easy to add. And then the procedure body is really the same. It doesn't have the check procedure thing in it that I've created, but it does have the insert, basic insert, update, delete procedures. And that gives you a good starting point. So that's one option. Another option, demo, that was the demo. The other option, or another option, is QuickSQL, which is part of Oracle's Live SQL. You can get to it directly, the QuickSQL, directly through quicksql.oracle.com. And do I have that up? I don't. Okay, but we can show it. Now you have to have an Oracle account, which is free. So if you don't have one, you can create one. And there's no fee or anything for this. But when you get into Live SQL, there's a number of options. There's all these other tools. SQL Worksheet will let you connect to different types of databases and test things out just as you would do in SQL+. But QuickSQL, you can define tables like departments and then say ID, name, date, start date, things like that. And it'll read the kind of quick shorthand definitions and create code from it. And in this case, it's creating a table. But you can also say /API, if you can spell API. It's very hard. And then generate SQL. And it creates a a package with a get row. Get row is actually the select. So this is not something that I've talked about yet, but it does also the insert row, update row, and delete row. And if you look at the body, get row is the cursor, but if you do insert row, it's very similar to what we've just been looking at, update row, delete row. So this is an example or another possibility for creating a table API, but this is really good for creating tables maybe that don't have tables that you can use for prototyping and kind of user acceptance testing in as far as design. It may not be the tool you use for the full production version of all these. It's got quite a lot of variations and capabilities, and it'll actually do sample data. You can actually have it generate sample data. There's some of that in the samples here. So if we have, this is one of the examples, you say insert 4 and it creates insert statements for sample data. Or if you want to insert 40, then it'll insert, create insert statements for 40 records. So you can get all that going and get prototyping done really, really quickly with this. If you've got the tables created already, the table API generator in SQL Developer is probably the best option. But again, look at those other two tools that I gave examples or links for at the beginning of this talk, or at the beginning of this section, to see if those would handle what you need better. There's some YouTube videos too about how to manipulate quick SQL and make it do lots of great things. Yep, demo 6, that was it. That's the screen. Okay, so why use thick? Faster performance because there's fewer messages going back and forth. And if you use views, you're reducing number of round trip messages and saving cloud costs. This is one you can convince your boss about because they're saving money. Because you're saving, anytime you save network traffic and compute time, you're saving cloud costs. Also using staff properly, so you can have developers working on the user interface, which they know and love, and database developers working on database code, which they know and love, and they can concentrate on what they do best, and then they coordinate their their efforts. So, and it also greatly simplifies user interface code because you're not mixing in SQL with whatever the user interface code is, or PL SQL even. Some changes require less rewriting. I mentioned if the user interface development language changes, then you have to change a lot of the code if you've got SQL statements buried in the code. Also, table refactoring, if you're changing columns or just changing names and you've got database views on those tables that are being changed, it may be that just the view changes and not the user interface code changes. So there may be less rewriting that way. You can use it with any development tool. So, Apex Forms, ADF, MAF, JavaScript, all types. They may have a layer in the middle, like ADF has ADF business components, or Java code has Java beans. JavaScript, REST services, and MAF would have a web service, but they all go through the table API. And if you're using views, it goes through views. So it's kind of regardless of which technology you're using. Better performance is the kind of the first one and the main one that I mentioned. And the proof of this is in Toon Kopelar's research, which he's documented in a YouTube video. If you look this one up, you'll find it. And I've given you some links later in the presentation. So I've actually copied some of his content from some of his slides with his permission to show you what he's done. He's using the term SmartDV, which he wanted me to be sure that we're clear on because he's working for Oracle. And he did a test with row-by-row processing for an application in Java with no additional framework, just plain old Java. And then application in PL SQL. And I said not recommended because it's row by row. Recommendation is to do set processing. So he did another application using set processing, which is better. And these are the results. So row by row well, again, a little bit more about this test scenarios. 5 million rows, various SQL statements, and capture the time elapsed and the database CPU usage for both methods, PL/SQL and Java. So the results were no PL/SQL, which is the Java. The elapsed time dropped by 3 times when you went to PL/SQL, so it's faster, and then the CPU usage dropped by 2 times, so it's more scalable. Fewer app servers needed to scale for more users. And the reason was mostly because of the Java startup and shutdown for each statement. Multiple statements, 5 million statements means 5 million Java startup and 5 million Java shutdown. And that was quite a bit of extra effort, plus the messaging back and forth across the network. So if you try to compare with the set-based, even the PL/SQL to no PL/SQL, the PL/SQL set-based to the Java, it's 62 times faster. So obviously you want to use set-based, multiple rows, multiple row insert, multiple row updates if you can, but PL/SQL in general is faster and less CPU usage. So drawbacks are you need time and effort to incorporate it into your environment, and you have to spend some time on design because there's no one way. You have to think about what's best for your environment. You could take my examples and use them or modify them or somehow incorporate them. And then documenting the standards because you want to be sure that everybody's on board and using, doing code reviews or things to make sure people are using it. And then instructing everybody on how to use it. On the IT shop side, it's helpful to have a fairly high level database designer type person who can do the low level code or the generator, talk about, design the generators and then also talk about the benefits and be sold completely on this system. But if you're doing some kind of generation, then it's very important to have an expert coder as well. But you need buy-in from management because some of this takes up time that's not productive. I'm not going to say productive. That's not specific to a project, right? It's doing architecture and development environment setup, which is always the hardest thing to sell people on. When not to use thick database? Well, if you're dedicated to database independence, which means you might be changing from Oracle to SQL Server, which is not simple, but could be done. You wouldn't want to use this. Some product companies have to be database independent, but you'd be using ANSI SQL, you wouldn't be doing thick database. If you have a few or simple business rules, then the overhead is probably too much. I don't know too many systems. I've never worked with a system with simple business rules, but you may have them. Okay, some variations. Oh yeah, we have to have a quote in the middle here from Yogi Berra because we're talking about thick. So it's very important to know what his review was for the Marriott Marquis in New York. This was yesterday. Geez, staying in Marriott Marquis yesterday. Amazing. So variation is you saw the get routine that I showed you from QuickSQL. This is something that you could add for selecting data. So you could be calling a procedure to select data instead of just a select statement. But the virtual private database policies can filter data if you've got some business rules that are needed to be implemented for selects. And they can do pretty much what you need. Data safe is another option, Oracle's data safe for hiding data and manipulating data. But when you do this, you're responsible for handling the result set. So you've got to figure out how the user interface can handle the collection that's sent back from a function like that. And you may need more code to do that, but you do have more flexibility. Do you need an Oracle database? That's a good question because this is an Oracle oriented group, but there are people, environments that have Oracle and other things, but you do need a central location for business rules code, and database is a good place for that. Views are needed if you're using method 2 to hide the details of the storage, and then, instead of triggers may or may not be there in different databases. So application has to call the code. The table API concept may be possible if you're using DB2, which supports PL/SQL, or Postgres, which has a PL/PG/SQL, which is very much like PL/SQL, and that is an option too if you're using Postgres. You can always just have access to views and not tables, and that gives you some of the benefits. So transitioning to thick database, this is like any other standard. You don't want to do it by converting all of your existing enterprise applications to this system now. What you do is you apply it to new applications and enhancements for existing applications. Starting small is a good idea. If you've got a small application that you're doing, it's good to start small, and then refine that as you go. So, completely thick is just a longer term goal. So this is just talking about having the team divided into user interface developers and database developers who do their thing separately, but then they're coordinated, and each group is using the skills that they know and like to create their code, instead of having Java developers invent data or do database design, which is possible and works in some cases. But if you've got database people, it's better to have them do what they like to do. So divide and conquer, that's the idea. Okay, resources. I'll just fly through these really quickly because we're getting close to running out of time. So Dalcian, I mentioned, Dr. Paul Dorsey's company has some white papers and presentations out there that explain this a little more. Stephen Feuerstein has a PL/SQL and EBR blog, and there's also Toon Koppelar's YouTube video, which you want to watch to get his proof on his test of the 5 million row system, and a bunch of other links here. And more Toon, he, before he joined Oracle, he was talking about this as well. And the SmartDB office hours is part of Ask Tom. So if you haven't looked at Ask Tom, it's a good thing to look at. They've got PL/SQL office hours as well, which I mentioned at the bottom. And then Mike Smithers has talked about this as well. So summary is the thick database emphasizes database code, and you can use it to improve the user interface simplicity, productivity, because you're using your staff in the best way. Performance, this is the main goal. And application accuracy, because you're tracking your business rules as you go. And security, because you're protecting your code and your database objects and the data as well. But there's no one way to do this. Table API, which is the focus of this talk, is really the core technique. That's what you're doing. All the code is based on. You're calling this from from either view triggers or from the client directly. It's two different methods. And you just need to plan in some ramp up time if you're not doing it already. If you're doing part of this already, you may be actually doing table API, but some of the other concepts may be things that you want to work in. Using a phased approach is a good idea. Starting small, starting with new applications, and then kind of working into the main system. Right. So these are the books that I've helped work on, and I want to thank everybody for attending MOUS Monday. And again, the code examples are here, and the slides with the video and the QA document I mentioned will be on Mike's blog here, which I'm sure you all know about, and he'll send a link to later.
Yes, I'll have it on there, and I'll have it on the MOUS page as well as a PDF file. So
on the MOUS page as a PDF, right? So you can get to it. You won't have any excuse for not getting to it.
Yes.
All right. So any questions? I don't see any questions on.
Well, I had a couple comments. I just wanted to say that it can't be understated as the Live SQL website. Awesome. I used it a couple of weeks ago, and I thought, wow, why haven't I been using this all along?
Right.
That's number one. Number two, I like to just compliment you, because I see about 1 out of 10 applications written like this, and a couple things that, which is sad. It really is sad.
Yeah.
but because I think because of time, I think
Yes.
developers are given so much time, and it's like, here, we'll just fix it later. I like the fact that you can ramp up. But the other thing was that two things that can't be stressed enough is the performance part of it, and you stress that pretty well. But the security aspect of it, I can't tell you how many applications everything's in one schema. So, and when you have to start granting access and then start doing auditing and all that kind of stuff, it makes life miserable. Yeah, this helps out quite a bit. So that can't be understressed, especially the security aspect of it. It makes it much easier. Unfortunately,
I was going to say it's really an important part of this technique. Actually, this division of the code and database objects.
Yeah, it's just, and it's unfortunate because I'm on the database end of it, and I see this, and I see so many people doing it this way, and I just and then I get, you get the typical responses, which are, oh, we didn't have enough time, we just, built it, and we didn't think about it. There's no right or wrong code; it's just what works, kind of thing. But this makes life a lot easier if people more applications were to do this. So, thank you for. I learned something today. So,
wow,
thank you so much.
Amazing.
So,
right.
Well, you always learn something,
Well, good. I'm glad to know that. Yeah. So it wasn't a waste.
I like the fact that I didn't know you can generate the API part of it, or the from SQL Developer. Didn't know
yes, you can. Yeah,
how dumb. It's
yeah, the kind of underused thing, and that quick SQL is definitely an underused piece. You said live SQL. When I ran into quick SQL, it was like, I think 6 or 8 or 9 months after it had been developed, and I saw it being just demonstrated at a conference, and I said, "How did I miss that?" It's like the best kept secret.
I was thinking.
Wow.
Anyhow, well, thank you.
Very good.
It was a great presentation. Thank you, Mike. I don't see any questions, but I'm sure they'll be posting some here after. Okay. We tend to get more people probably watching it after as well.
Right.
So.
Okay, sounds good. Anyway, very good, Mike. Thank you.
Thank you, Peter. I appreciate it, and you have a great day.
Okay, thanks. You too. Take care. Yep. Bye-bye, everybody.
Yep. Bye-bye.